A is a point 2, 0, B is a point 2, 5, and D is a point where the tangent to the point where the tangent to the curve y is equal to x squared plus 1 at B crosses the x-axis as shown in the diagram. The tangent meets the y-axis at E. Find the area of triangle ODE, and find the area of the region bounded by the curve y is equal to x squared plus 1, the tangent and the y-axis. So finding, first of all, the x-coordinate of D, and then we'll find the x-coordinate of E as well. So to do that, we need to know the equation of the tangent, the blue line here. So y is equal to x squared plus 1 is the curve. So if we differentiate that, we're going to get dy by dx is 2x. At the point where x is equal to 2, so when x is equal to 2, because this is the point where we got the tangent, dy by dx, which represents the gradient, will be 2 times 2, which will be 4. So the gradient of this line is 4. And then if we find its equation using y minus y1 is equal to mtx minus x1, where mt is in fact 4. And we take this as a known point on the curve. So we got the equation of the tangent will be y minus 5 is equal to 4 times x minus 2. So that gives me y minus 5 is 4x minus 8, and y is equal to 4x minus 3. It's better to have it in this format here. Okay, so taking that tangent, we're just going to mark it on our graphs. It's a good idea to annotate the diagram as you go along. At D, y is equal to 0, so we'll put 4x minus 3 is equal to 0. That's going to give that 4x is 3, x is 3/4 or 0.75. So the x-coordinate at that point is 3/4. The y-coordinate we can get from y is equal to mx plus c, where i.e. x is 0, so y will be 4 times 0 minus 3, which is minus 3, but we can get it straight away from that point there. So we'll mark on that point as minus 3. So we can find the area of this triangle, because the area of that triangle will now be 1/2 of base, which is 3/4, times the height, which is 3. And if we work that out, we're going to get 9/8 square units. Okay, for part B, we've got to identify the area that we want. We want the area bounded by the curve, the tangent, and the y-axis. So it's going to be that area plus that area. But how are we going to do it? We've already got this triangle here. What we're going to do, we're going to find this area here by integration, and then take away that triangle, and also add in that triangle to get the area that we want. So the area under the curve, so this is going to be this area here, between x is 0 and x is 2, will be the integral of our curve, which is x squared plus 1 dx. That will give me x cubed over 3 plus x from 0 to 2. So that gives me 2 cubed over 3 plus 2, substituting it in, minus 0. Now be careful when you put 0 into an integral, but just make sure everything is actually 0 if you're just going to write minus 0. And that will give you 14/3 square units. So that gives me this area here. Right, what we need to do is find this area here, so that this is a triangle, so the base will be 2 minus 3/4, and the height of the triangle will be the y-coordinate, which is 5. So the area of triangle DAB will be 1/2 times 2 minus 3/4 times 5, which gives me 25/8 square units. So the shaded area that I want is going to be 9/8, which is the triangle here, plus all of this area here, which is 14/3, and then take away 25/8, which is the area of the triangle, and when we work that out, we get 8/3 square units. Okay, so there's been a video to show you how to find the area of a shaded area using integration and areas of triangles. I hope you've understood, and I thank you very much for watching.